So today I want to explain how to prepare a CNC part program for making contour milling on the workpiece. Now let us see the diagram. Now this is the shape of the contour I want on the workpiece. So based on these dimensions, let us choose the workpiece. The workpiece size is length is 120 mm and width is 100 mm, thickness is 10 mm. So for making this contour on the top surface of 2 mm depth. Okay. Now let us write a part program for making this contour on the workpiece. Okay. Now before going to write a program, first of all, by seeing this diagram, we need to identify which point we are going as a horizon point, and with reference to the horizon point you can calculate all the dimensions. Now let us I am taking so these are the points I assigned. This is the point here. This is the workpiece, that billet size of the workpiece, and here the bottom left corner is taken as a horizon, that is xy, and with reference to this I want to calculate all the coordinates of these points. I assigned all the points in clockwise direction starting from this point. This is the point 1, point 2, point 3, point 4, point 5, point 6, and point 7. So you can decide what is the movement of the tool, how the tool is moving, and which tool you are going to. Here I am using the end mill cutter of 10 mm diameter. Now the start from year 1, tool is moving in this direction. 1 to 2 is a linear movement, and 2 to 3 again linear movement, 3 to 4 also linear movement, and 4 to 5 the tool is moving in this direction. This is the counterclockwise direction. Again 5 to 6 is a linear movement, and 6 to 7 is a clockwise direction, and 7 to 1 is a linear movement. So once if you know the what type of movement, accordingly you can write a part program. Okay. Now let us calculate the what are the coordinates of these points before writing the program. That is the best habit. First find out all the coordinates, then start writing the program. Now let us see that already I calculated all the dimensions with reference to the horizon point. From this point, point 1 is x is 10 mm and y is 10 mm. Okay, and that point 2 is 1080, point 3 is 2090, point 4 is 190, point 5 is 110 and 80, and point 6 is 110 and 20, and point 7 is 110, and point 1 again starting point 10 and 10. So I calculated all the coordinates. Now all the data is available for write the part program. Now let us see that using this CNC train simulator system. So before writing this, just you have to set the billet settings. Okay. Now you can see that billet settings, the billet length here, the billet length, what is the length you have taken, that you have to consider here. Let us here I am taking the length is 120. 120 is the billet length, and billet width is 100, and the depth is 10 mm, and x shift, y shift, z shift is 0, that is the bottom corner is making the horizon. With reference to that it will take the all the values. Okay, so this is the billet settings. Then go for the tool offset. So here the tool number 1 is I am taking the end mill of 10 mm diameter. Okay, now this 10 mm diameter end mill is loaded, then it click OK. Okay, then now you can start writing the program. So first we'll write G21, that is the metric units, and G94 feet per minute, and here whatever the portion of the tool earlier is there, better you can take the incremental mode. For that you can assign the G91 is the incremental mode. Then send the tool first to the reference point. For that G28 you are using G28 Z0. So then send the workpiece is the reference point X0 Y0. Then you can change the tool. The tool is M06 T01. So end mill cutter is assigned to the number 1. Then spindle starts rotating. For that M06 is a start rotating clockwise direction. Not M06, M03. Then the what speed that you can assign, let us S 1200. So that is the speed. Then now earlier the incremental mode is there. Now you can bring to the absolute mode, that you can assign G90 is the absolute mode, and rapid movement G00 is the rapid movement. Now you can bring the tool to the point 1. So what are the coordinates of point 1? X is the 10 and Y is the 10. Now let us here this X10, then Y10, then just I am taking the 5 above the workpiece for safety. Just I have to bring the tool from the reference point to the tool entry point. Just I taken 5 above the point 1 is the tool entry point. So that coordinates I entered here. Then the tool will go to the inside the workpiece. So that here that is a linear movement G01, then Z, let us I am taking the 2 mm depth, Z minus 2, then with a feed 90, okay. Now the tool is at point 1. Now the tool is moving from point 1 to 2 in the linear. Already G01 is there, and X coordinates is same, Y coordinate changes. Then you can enter here is Y coordinate is 80. Now the tool is moving from 1 to 2. Again from tool will move from point 2 to 3. So now 3 point coordinates you can enter. Here X and Y are different. You can enter both the values. X is 20 and Y is 90. Okay, now the tool is at point 3. Again the tool is moving linearly from point 3 to point 4. So now the coordinates of point 4 you can enter. Point 4 X value changes, Y value same. So you can change the X value. So the X is 100. Okay, now the tool is moving to the point 4. Again the tool will move from point 4 to 5 in a counterclockwise direction, that is a G03. G03 is counterclockwise direction, and X value is 110 and Y value is 80 and radius is 10 or 10 value. Okay, so now the tool is reaching the point 5. Again from the point 5 to 6 linear movement. Again you can change this G01, and the X value same, on only Y value changes. So then we have to enter the Y value, that is the Y20. Okay, now the tool is coming to the point 6. Again tool will move from point 6 to 7 in clockwise mode. So again for clockwise G02, and X value is 100 and Y value is 10 and radius is 10. Okay, so now the tool will come to the point 7 in clockwise direction. Okay, again from the 7 to 1 the tool will move in a linear movement, just G01, and here the Y value same and X value is only changes, the X is 10. Okay, so now the tool is at a starting point. Now we lift the tool. So for that you are again bring the tool to the 5 mm above the workpiece. Then tool will send to the reference point, that is a G28. First to send the tool Z0, then X0, Y0, workpiece sent to the reference point, then spindle stop M05, then program end and rewind, that is the M30. Okay, so this is the required code for making the contour operation on the workpiece. Now let us see that for simulation. So let us, you can reset, start. Now you can see that both, you can see the top view and front view, how the tool is moving, you can see that. So now, so this is the required contour is happening on the workpiece. Okay, this is the end of the program. Okay, so likewise we need to write a program to make the contour of the required shape on the workpiece. So here I taken the 10 mm diameter. If you take the 5 mm diameter, accordingly you can, so that this width maybe the less will come. Accordingly how much the width slot is there, that number of tool, that tool you can assign, and you can perform the operations. So with this I hope all of you understand how write a code and simulate for the simple contour milling operation. Thank you.